I'm Tammy Kolda, an applied mathematician, and this is Unlocking LaTeX Graphics. On this channel, I present tutorials on using TikZ and PGF plots. The videos on this channel are based on my book, Unlocking LaTeX Graphics, as well as some bonus materials. Today, I'll show you how to use radian angles in TikZ. This is a redo of episode 66 because I had a subtle bug that I'll talk more about later. By default, TikZ expects angles in degrees. However, it already has the built-in functionality to convert from radians to degrees on the fly. So you can write your angles in radians if you prefer. I want to give a shout out to viewer CAW25SHA for originally asking about this, and to viewer 08ACBEST for catching the bug in the original episode. Thank you both. I'll show how this works in two ways. First, I'll show how radians can be used in specifying a polar coordinate. Second, I'll show how to create a node.angle anchor using radians. Let's get started. Here's our document setup. I use parskip to avoid paragraph indentation and hyperref to link the author name to this YouTube channel. The main package is TikZ. I'm also loading the TikZ math library. This is what gives us access to the degree function, which converts radians to degrees. I'll link to my episode on TikZ math functions in the show notes. In the TikZ set block, I'm appending the help line style with a light gray so it shows up better on the video. I'm also defining a style called point. It makes the node a small filled blue circle with a minimum size of 3 points and intercepts 0. I'll link to my episode on TikZ styles in the show notes. Before we talk about conversion of radians to degrees, let's start with a quick refresher on polar coordinates in TikZ. A polar coordinate is of the form angle colon radius. The angle is specified in degrees and the radius is the distance from the origin. 0 degrees points east, 90 degrees points north, and so on. Here I'm drawing a 2x2 help grid, then I draw a line from the origin to the polar coordinate 45:2. That means the coordinate is at an angle of 45 degrees and a distance of 2 from the origin. I also place a small blue point at each end using the point style that I defined above, with a label below the origin and a label of pi/4 at the other end. The label key was covered in a recent mini episode, which I'll link in the show notes. The label says pi/4, but the angle is written as 45. That's because TikZ wants the angle in degrees, but mathematically we usually think in radians. Wouldn't it be nicer if we could just write pi/4 directly? That's where the degree function, just DEG in the code, comes in. The degree function takes a value in radians and returns the equivalent in degrees. It's available from the TikZ math library that we loaded in the preamble. One subtlety is that the angle must be an integer, and the degree function returns a floating point number. In this case, the degree of pi/4 is exactly 45, so it works out. But if we had an angle that didn't convert to an integer, TikZ will just lop off the decimal part and use the integer part as the angle, which could lead to a slightly wrong answer. To be safe, therefore, you always want to round the result of the degree function to get the nearest integer. So let's see what happens when I replace that code here. I replace that with the pi/4, recompile, and there is no change. One thing I'll note is that I'm wrapping the math expression inside curly braces. That's important. If you want to use a math expression as the angle inside a polar coordinate, the key is to wrap it in curly braces. The math library has already defined pi as a constant, so we can use that in our expression. Now the angle in the source matches the label. The other place we can use the degree function is with node.angle anchors. I covered node.angle anchors in a mini from episode 64, and I'll link that in the show notes. The short version is that for any node, especially a circle node, you can reference a point on the boundary at any angle by writing node name.angle, where the angle is specified in degrees. So here I'm going to start a new TikZ picture with a 4x4 help grid. Then I create an orange circle node named A at the center with a minimum size of 4 centimeters. Now I'd like to place a point on the boundary of A at an angle of pi/4 radians. In the previous mini, the angle anchor took an integer in degrees, like A.45, but here I want to specify it in radians. The same trick works. I can specify my round degree pi/4 function, and then I'll get my point on the boundary. I've also added a label of pi over 4 to the point. Let's add a few more points around the circle, all specified in radians. Each one follows the same round of degree pattern. This code adds points at 2 pi over 3, pi, and 3 pi over 2. There we have it, 4 points placed on a circle node, all using radian angles converted to integer degrees via the round and degree functions. If you forget to add the round, it actually won't have a major impact. In fact, that's what I did in the previous version of this episode. But you might be off by 1 degree. So our astute watcher noticed that if I did not have round on this last one, it was slightly off. It's so subtle that my poor eyes couldn't see it. But if we zoom in here, we can see that this is not exactly at 270. And that's because I don't have that round. So if I put that round back in, we see that now it moves to be exactly where we expect it. So that's the subtlety of adding round. Thanks again to viewer at 08ACBest and their great eyes for catching this in the original episode. I hope you enjoyed today's redo of episode 66 on using radian angles in TikZ. We saw that by loading the TikZ math library, we get access to the round and degree functions, which lets us write polar coordinates and node angle anchors using radians. The key correction versus the last episode is that you need to wrap degree inside of round to ensure non-integer angles are mapped to the closest integer. Be sure to wrap the math expression in curly braces whenever you normally write a numeric angle. I include a link to the overleaf document I created today in the show notes. If you found this helpful or interesting, please click like or subscribe. Thanks again to viewer CAW25SHA for the question that inspired the original episode, and to viewer 08ACBEST for catching the mistake in the original episode. If you have questions or suggestions for future videos, please post them in the comments. If you want to learn more, please check out the other videos. I also have a book, Unlocking LaTeX Graphics, available for purchase at major book retailers. Thanks for watching.